Of course, it supports lists, tuples, sets, dictionaries, and sequences. But what is the difference and what are the different operations that can be used? What are the similarities and where they can be used? So we'll see that. In addition to that, for the processing of the list, we have a concept called as list comprehensions, and that we'll see in this class as part of this unit. May not be in this class, but in the future classes. So let's try to understand why we should basically study the data structures. Is it really required to understand the study of the data structures? So of course, yes, because they are the fundamental concepts of the computer science. Why? What is the reason? Why did they become the fundamental concepts? Means they help us to write the efficient programs. So what do I mean by efficient here? So what is the difference between program and efficient program? Say for example, I'm given two different programs, like linear search and the bubbles, linear search and the binary search. So which searching do you opt for? So I'm given you two programs, the linear search and the binary search.
Binary search.
Yeah,
binary
why?
search.
What is the reason? Yeah, fast. Is it always binary search? Can you apply it on any set of data, the binary search?
Only sorted list.
Yeah, very good, very good, very good, very good. So only on the sorted list you can apply the binary search, right? So if you know that, if you have an idea about the data, if it is sorted, then you can apply binary search over the linear search. The reason is it is efficient. So what is the meaning of efficiency? Someone answered actually. I appreciate her. Yeah, tell me what is efficiency? Yeah, takes less time. So whichever executes faster, those are called as efficient programs, right? So basically data structures are the ones which allows you to write efficient programs. So if you choose one kind of data structure, it may take more time. If you choose other kind of data structure, it may take less time. Okay, so that's how data structures also helps you to improve or write efficient programs. So what are data structures basically? So data structures, they provide us a way of organizing and storing your data. Say for example, if it is what is this? The first video shows what?
Stack.
Which kind of data structure? Yeah, it is stack, right? Yes, exactly. So where the stack is a data structure which allows you to organize the data in which order? Last in, first out. So you can insert an element and you can remove an element from the same end. So the last element that you are inserting is the one that you are taking out, right? So that's how the stack data structure works. And if you consider, so the second video, it represents the, what is that? It's a queue. So queue follows which kind of operations? The first out. Very good. So first in, first out data structure. That is whatever the element that you are placing first, that element has to be processed first, right? So that's how it's called as first in, first out data structure. So different ways of organizing the data. Here you are organizing in the last in, first out, but here you are organizing in first in, first out. So that is how data structure provides us a way of organizing and storing the data. So if you remember, no, the array and linked list. So how the memory is allocated in case of the like linear and the non-linear data structures. If the data structures are linear data structures, then how the data is or how the memory is allocated for these data structures, linear and non-linear. Do you remember? This is the very, very basic question of data structures and very, very important.
Point.
Huh?
Point.
Dynamic array is a linear or non-linear data structure?
Linear.
Linear data structure. When do you call a data structure as a linear data structure?
Sequential data representation.
When the memory is allocated for the data structures in consecutive memory locations, then it is called as linear data structure. Then what is non-linear?
Dynamic memory allocation.
Dynamic memory allocation. So the allocation need not to be in the sequential memory locations, right? So such data structures are called as non-linear memory location. And yeah, so Python also provides certain primitive data structures. Like for the numerical data, you have integer, float, and complex. And for the Boolean data, you have the true and false data types, right? And in addition to the primitive data structures, we also have a list of non-primitive data structures called list, tuple, dictionaries, sets. Of course, we have the strings also. So they are not considered as part of the data structure, but they are considered as part of the sequence data, which can store the data in the sequential order. So if you observe, these are all the different data structures that are supported by Python. So under the numerical data structures, you have the integer, complex, float. And in addition to that, you have these complex data structures. And if you observe the string, list, tuple, they are called as the sequence data structures. So why we call these data structures as sequence data structures is they follow some sequential order in storing the data. That is, so you can see, so say for example here, if you observe, these are the examples for different data structures. So it's a list, it's a tuple, it's a set, and it's a dictionary. So if you observe here, so here I can say that this is the first element, this is the second element, this is the third element. Is there any ordering in the elements or not? Yes or no? In this case, yeah. So in case of the list we have, in case of the tuple also we have, but in case of the set, so do you remember that your 9th class or the 10th class, you must have studied sets. Do you remember sets? Is there any ordering between in the ordering of the elements in the sets? No, right?
No.
Whatever order you write, it's all the same only, right? Two sets in the same elements, same sets of same elements, even if they are written in the different order also, so they form the same set only. Please try to recollect them. So that's what the difference is. So these list and tuple, they are called as, of course, string also, they are called as a sequential data structure because there is an ordering among the elements. But these data structures, set and dictionary, they do not have any ordering among the elements. So that's the basic difference between these sets of elements. So now let's see, start our discussion with the list. So we discussed, right, about the list so much. Actually, we have discussed again. So let me kind of give you a brief review of it. So list is basically a compound data structure. So why do I call it as a compound data structure? Why do I call it as a compound data structure?
It contains all kinds of data.
Of course, it can contain all kinds of the heterogeneous and also homogeneous also. So basically, it can contain a collection of arbitrary objects and the collection of elements you can have. So if you consider an integer value, how many values you can store in a variable? Say for example, I'm going to create an x with the value 10 I'm assigning. So how many values you are storing in x? How many values you are storing in x? Only one, right? So integer. It's a scalar data type, right? Integer is a scalar data type where you can store only one and only one value. So now let me create another variable. So 12.5. So now what is the type of y here? It's a floating point value.
Float.
So you are able to store a floating point value in y, right? Yeah. So how many values you can store here? Only one value. So you cannot store more than one value. But in this list or tuple or dictionary or set or in string, you can actually store the collection of elements. So that's how they are called as the, non-primitive data structures, where more number of primitive elements can be part of your non-primitive data structures. Fine. So lists are mutable. So can you justify this statement? Lists are mutable.
We can add.
Yeah,
Can be modified.
exactly.
You can
Yes,
modify
exactly.
it.
Good, very good. So once you create a list, so you can later update the elements in your list. So that is, you can insert new elements, you can delete existing elements, you can update the old elements, you can remove them. So all these can be possible on the list. That's why they are called as the mutable elements. Of course, you can have the list inside the other list. So they are called as a nested list, similar to your nested if, nested for loop, nested while loop. You can have the list inside the other list also. And lists may contain any sort of objects. Maybe it could be the numbers, it could be the string, it could be any other types of elements also. Even a list also can be part of your list. So that's a brief about the list. So maybe here you can have samples, see some set of examples of the list. So here the list is created with all the even elements, that is of the integer type. So this, can I call it as a homogeneous list where all the elements are of integer type? right? And now I have the list with all the strings where each element is a string. And here I have a list with different data types. So what is the type of this list?
Heterogeneous.
Heterogeneous list. Now let's see how do we create the list. So always lists are created by using the square braces where each element is separated with the list. So here we have an example, right? So you are enclosing the list of elements in square brackets, and every element is separated by a comma. And let's see how do we create an empty list. This I haven't shown right earlier in the earlier classes. So this is how, this is one way to create your list. See, so actually L1 is nothing, it's an empty list only. So because nothing is there, but still it is a list, it's called as an empty list. So if you want to check, you can check the type of the list using the type function. See, so it's a list type. So now you have another way also to create a empty list, an empty list. So now we have a list function. You can, that is a list constructor you can use to create an empty list. Now let's check L2. So L2 is also a list. And what is there in L2? Nothing is there. Okay. So these are the two ways you can create an empty list. So this is the first way, using the just empty square braces, or you can use the list constructor also. So L2 equal to, so the list, so with empty arguments. So that's how you can create empty lists. And once you understand how to create the empty list, so let's see how do we create the list with elements. So anyhow, we have discussed it for multiple times because the concept demands, I'm repeating that. So this is how you can create actually a list of numbers, maybe integers. So that's a list with integers. So now I'm going to create another list, 20.5, 30.5, 40.5. Now this is a list where each element is of type. What is this type? Float. What about this? L1?
Integers.
Integer. And now I'm going to create a list with all the elements as characters, maybe Vignan. So let me VIGN A L. See L3. So now let's try to display. If you want to display, just use the statement. Because you are in the interactive mode, no, you can just display. Sorry, L4 is not there. So this is how you can display the elements, and you can have actually lists with integers, lists with floating point numbers, lists with characters also. And even I can create, of course, a list with strings. So maybe I'll create a list with Ram, Ravi, Raj, something like this. So now I'm creating a list L4 with list of strings. Each element is a string if you observe here. Now I'm going to create another list where I have a list as part of the other list. I'm going to create 3, 40, 50, and I'm going to have one more list as part of this list. Now this element is then L5, right? So this is how you can create any type of list. So list with homogeneous elements of type integer, of type float, of type character, of type string even. So a nested list, maybe I'll create a list with heterogeneous data with the Vignan as the name, then roll number could be something, then your CGPA is something like 5.6. So this is how I can create a list with heterogeneous data where the first element is a string, second element is an integer, third element is a floating point number, right? A heterogeneous list. So that's how you can create different types of lists basically. Now let's see how do we access the data from the lists. How do we access the data? So here, because it's an interactive mode, you are displaying the list like this. But when I create the list, yeah, let's see this. So I'm going to create a file. So inside the file, so now I have created and I want to display this. So is it okay if I let's sample? Is it okay if will it be displayed? See, so I just created a list and I want to display the list. And this is the program. This is the kind of script mode. I am in script mode. I've created a file, and in that file I am typing the code. Now I want to run this code. So nothing is displayed, right? So because when you use this, just the list name, it will not be displayed. Remember, even the variables also, in the interactive mode, it will be displayed. Don't get confused, okay? So when you are in the script mode, you need to use print function to display any variable. When you are in the interactive mode, directly you can get the values when you type the variables. So that's only for the practice purpose we are seeing. See, so when I use the print function, so I can get this value. So yeah, now can you tell me what is the expected output of this?
2 times of
Yeah, exactly. Very good. So what do you call this operator? Right. So if you want to repeat a list or any sequence data structure for that matter, if you want to repeat, so whatever the number of times you want to repeat, you can use this. So with an asterisk symbol, okay, and the number of times. So if you use it for 20 times, no, or 10 times, the list will be repeated for 10 times, all the elements. The first time, the second time, the third time, so on and so forth for the 10th time. So that's how you can use this operator. Yeah, tell me.
Suppose if we want to create a list L5 like including the data of L3 and L4, can we write like L5 equal to list of
Okay,
L4,
let's see that. Let's see that. So we have L1. Okay, oh, L1 is not there with us. What happened to L1? Empty list only we created. Okay, let's create this. So we are creating L1, and L2 is whatever is there in L7. Okay, so this is how you can actually assign. Oh, sorry, L7 is also not defined. Fine. L6, L5. L5 is also not there. Fine. What happened? Okay, only L3. Up to L3 only we created. Fine. So this is what. Okay, let me create. Try to test. 100, comma 200, comma 300. So this is what L3 is. Now I have L1. So these two are L1 and L3. Now I'm going to create L2. So you want me to do L1 plus L3, right? So you want to get a new list L2 with all the elements from L1 and L2. So here, when you use plus operator with the list, it acts as a concatenation operator. So what is L1? It's 1, 7, 2, 1. So to that list, so these are the elements of L1. And to that list is 100, 200, 300. Those elements will be concatenated, and your new list will be created as L2, and that we are displaying it here. Did I answer your question?
Yes,
Who was that?
Yeah, yes,
Yeah.
ma'am, your answer. Thank you.
Good. Yeah. Next, any other questions? Now, let's see how do we access the elements from the list. How do you access? I want to access the first element of this list, L2. So I have L2. Okay, this is what L2 is. I want to access the element from the list. 100 I want to access. How do I do that?
L2 of 0. L2 of
100
index
here.
number. L2 of 4.
Very good. Very good. So you had to use a square bracket. So that is how you can access the elements actually. Square bracket 0, 1, 2, 3, 4.
4.
Right? So indices and all we have seen multiple times, right? So always the list index starts from 0 and ends at n-1. So the same, like however it is in the strings, or so we have already discussed about the list. So that's how the indexing starts at 0 and ends at n-1 if your number of elements are n-1. Say for example, I want to access the last element. How do I access?
L2 of -1.
Very good. In addition to the positive indexing, you can use the negative indexing also. So negative indexing starts at -n and ends at -1, right? And say for example, I want to access the elements from the second element to fourth element. How do I do that? I want to access multiple elements. So if you use the square brackets alone, then only one of the element can be accessed. Say for example, at the third index I want to access, I can use this. So at the fourth index I want to access, I can use this. Or using the negative index also, I can access the elements like this. I can access, right? But instead of accessing a single element, in all the cases only one element is retrieved for me. But I want to access more than one element. How do I do that? What is the operator you can use? Yeah, slicing you can use. So what is slicing? How do you use that? So basically slicing is the operator. With the indexing you can mention, so a start value, so then a stop value, and a step value,
increment,
right? Yeah, increment of step. Step and increment both refers to the same. So you can use a start, so you can use stop or end, whatever you call start and begin. So alternatively you can use stop and end, you can alternatively use. So then step is an incrementation, right? So this is the syntax for your slicing operator. So how it works is it retrieves all the elements which starts at this index with the index start and ends at the index stop -1 and with a step counter of this step value, right? Now let's see an example. Of course, here the step value is an optional value. And of course, the stop also can be ignored. So start and stop also can be ignored. So you can actually have, so there are three different colons right here. The first colon indicates the start and stop values. What is the range of values? And the second colon is to indicate the step value. So you can have, instead of having two colons, you can have single colon also. So like this you can write, right? So in that case, from every element from this index to this index -1, all the elements will be retrieved. So let's see the examples. Examples would be more meaningful. It makes more sense to check using examples. So second index to fourth index. Fourth index -1 is -3 only. So let's see. So second index to fifth index -1, 4. So what are the elements that are retrieved? In L1, L2, yeah.
2, 1.
2 means index 2. Remember, it's index 2. It's not the element, okay? So here index 0, index 1, index 2. So from this element, so then second index, third index, fourth index. Of course, fifth index is not included. So 2, 1 and 100 has to be retrieved, right? Got it? That's how you can use the slicing operator. Maybe you can ignore the stop value. When you ignore the stop value, what happens?
It returns to the end value.
From the start index till the end, all the elements will be retrieved. Okay, and you can even ignore the first index. So if you ignore the first element, what happens?
From the 0,
all the elements from the beginning, yeah, from the beginning till this index -1. So if you observe, this is L2. So this is L2. So this first index 2. So fifth index -1. That is still here, right? So that's how it returns these values. Now we can even display the values. Now let's display L2 again. Now in L2, I want to display second element to fifth element with an increment of 2. Yeah. Now tell me what are the elements that are displayed. Here you have L2. This is L2. Second index to fifth index
200.
Yeah. Second index means what from here? 2. Second index to 5 - 1 means 4. So 2, 100. And with an index of 2, with an increment of 2. So second will be displayed. Then after that?
Only 2, ma'am. 2 increment and then there will be no element.
Is it so? So 2 will be displayed. Then after that 2 plus 2, 4. Yeah, 4 is valid only, no? So 4 will be displayed. What is wrong in that?
Okay.
Right? So that's how you can use this. So now I want to display in the negative, like reverse direction, I want to display the elements. Right? So this is the actual list, and your list can be displayed in the reverse direction using this single statement. Only thing is, from start to end you want, but only thing is you want to get the elements in the reverse direction, right? So that's how you can use this negative incrementation to get the elements in the reverse direction. So when you use the negative incrementation, so if you don't use anything, your elements start from the end. Fine. So even you can, so maybe I can use something like, what do you want me to use? Or will increase the list size actually. So this is L1. So this is L2, this is L3, right? So create L4. L4 is created with L1 plus L2. What do I mean by this? What is your L4 now? Yeah, it's a concatenation of all these elements, right? So now your list is bigger. And I want to know how many elements are there in this list. How do I do that?
Length of L4.
Length of L4. 14 elements are there. And I want to check what is the type of L4. How do I do that?
Type of L4.
Type of L4. So what is its type? So its type is yes. How to add and remove? Yeah, I'll tell that. I'll come to that. So once this is done, maybe in the tomorrow's class, so you can actually append new element. So to L4. So maybe this is what L4 is, right? So I want to append a new element to the end of the list. I want to add 400. Okay, so this is how you can add a new element to L4. So this is what the earlier list is. So now your list becomes this. Okay, so automatically whenever you call append function and you had to pass an element, whatever you want to assign. So L4 will be updated by adding the new element at the end. Got it? So who was it? Who asked me this?
Ma'am, only at the end we can add, ma'am, by using
No, you can add it in the beginning also. So you have many other functions. Maybe in tomorrow's class we'll discuss each of the function in detail because it takes a long time. There are a lot of functions. Okay, so just to get that phase, to bring everyone to the same level, I just gave a recap of this. So L4, maybe if you want to insert a new element at the first index, okay? So I can make it as L4 of 0 is equal to 500. See, now my L4 is, so my L4 is created with the first element as 500. Of course, the first element you are updating. Yeah, so actually earlier it was 0, but you are replacing that with 500. So this is how you can replace. So there are many other ways also. This one way, just because you asked, no, so I'm giving the example.
Okay,
so let me continue. Actually, I wanted to explain some other things. So you can access the elements, right? In the nested list, we have created nested list. Where was it? Maybe we'll create a new list, L5. So L5 equal to, so let me create 10, 20, 30, 40, 60, 70. So now I have a nested list. So L5 of 0 is what?
10.
10, good. So L5 of -1 is what?
60, 70.
70. Yeah, that's what. This is a nested list. So just to stress that I gave this. So this is a nested list where one list contains another list. But even it is a list of elements, this will be treated as a single element only. Now let's check the length of the list. How many elements you have here? So these 4 are the elements. Even there are multiple elements also, because it's a list, it will be treated as a single element only. As far as L5 is concerned, so it is treated as a single element only. Do you understand?
Yes, ma'am.
Yeah. Now I want to check the type of the first element. How do I check? So let me create one heterogeneous list with the first element as Josna as the first element. So maybe my number is 101. My grade is 9.8. Okay, so that's how I'm creating L6. So now I want to check. So if you check the type of L6, what is its type?
List.
The list only. But now, can I check the type of the first element also? How do you get the first element? This is how, right? But I want to check the first element's type also. How do you do that? Type of, yeah, L6 of 0. So first element, this is how you can access, and even you can check its type also. Because the first element is a string, so you can check its type like this. Right? Now, let's see how this can be done. L6 of 1 is an integer. Fine. Now, if you see L6 of 2, it's a float. So you can, like that, you can check. Now let's see L5. Now I want to check the type of, what do you want to check? The last element, the list. It's a list, right? Now I want to check what is the type of this nested elements type. Is this single element? How do you access this element? I want to access this element alone. How do you do that?
L5 minus 1,
L5 of 4 of 1.
L5 of, okay, you can use a positive index also. There is no problem at all. So,
Yeah.
this L5 of 4 gives this. Yeah, let's see that. So L5 of 4 gives this element, right? This is how you can understand basically. Now, once you get that, you want to get this first element of that. So, right? And even I want to get the last element. See? Do you understand? Now?
Ma'am.
Yeah. What else is pending now? So this is how you can access the elements of the nested list also. So you can access the elements from the list, you can access from the nested list also, right? So I stop here. So I repeat, I continue with functions and all in the next class. Some question? Let me take that. 3 o'clock. Yeah. I'm leaving. I stopped it already. Yeah, you please remind. Otherwise, I